Hello everyone, welcome back to my channel HJR Contact. Today's my topic is binary subtraction. So this is one of the binary arithmetic operation. Already I uploaded one video for the binary addition and its link is given below in the description box. So please do watch that video as well as do watch this video till the end, because at the end I am going to add the number system conversion playlist where you can find all the videos for all kinds of number system conversion. And now let me start with this topic, binary subtraction. Before starting with actual example where we are going to perform the subtraction, first we must know what are the rules for the subtraction. So the first rule is, suppose I am going to perform subtraction of two zeros. So 0 minus 0. So when we subtract one number from the another number, there are two possibilities. First one is result and the second one is the borrow. First one is result of subtraction and second one is called as borrow. So 0 minus 0, here you can see both the numbers are same. So when we subtract the number from the same number, the result is 0, and in that case we don't have to take any borrow from the next column. So what is this borrow? Actually, suppose the decimal number is 5 and I am going to subtract 9 from the 5. So 5 minus 9, here you can see 9 is greater than the 5, so we cannot take directly subtraction. So I need to take borrow from the next column. So to make the 5 as 15. So it will become 15 minus 9. So in that case we can perform the subtraction. So whenever the second number is greater than the first one, we need to take borrow from the next column. Now consider the second case, or we can call it as the second rule of the subtraction also. Suppose second one is 1 minus 1. So here you see 1 minus 1, again both the numbers are same. So the result is 0 and no need to take the borrow also. Consider third one, 1 minus 0. Second number is smaller than the first one and second is 0 also. So 1 minus 0, the result is 1. As this is greater than the second one, we don't need to take any borrow. So borrow is 0. Now consider the fourth case in which first number is 0 and the second one is 1. So 0 minus 1. Now here you can see this 1 is greater than 0. So we cannot directly subtract 1 from the 0. So in such a case, I need to take borrow 1 from the next column and the result will be 1. So here you can see first three cases where both the numbers are same, borrow is 0. When I am subtracting 1 from the 1, that time also borrow is 0. Here borrow is 1. When we are going to perform the subtraction of 0 minus 1, borrow is 1 as well as the result is 1. Now I will add one more rule or one more case here, that is 1 minus 1 minus 1, because so many times you will need to know the result of 1 minus 1 minus 1 when we are performing the subtraction on the binary number also. So this is also very important. 1 minus 1 minus 1. So 1 minus 1, see the table, 1 minus 1, what is result? 0. What is left part here? Minus 1. From this result, I will subtract this one. So 0 minus 1. What is 0 minus 1? Borrow is 1 and result is also 1. So this is how we can perform the subtraction of 3 ones also. 1 minus 1 minus 1. Again the result is 1, borrow 1. So this is very simple to remember the whole table. Borrow is 0 when either both the numbers are same, or when the first number is greater than the second. And when borrow is required, whenever the second number is greater than the first one. Now let me take the first example. Suppose the given binary numbers are 1 0 1 0 1. This is the first binary number, minus second one is 1 0 1 1. Okay. Now I will write the first number 1 0 1 0 1. Okay, and the second number double 1, then 0, 1. Now you can see the first number contains 5 bits. Second number contains how many bits? 4 bits. So simply make the 5 bits also in the second number just by adding single 0 to the left side. If you don't write, then also no problem, but you have to consider, yes, nothing is there, that means 0 is there. So instead of considering, directly write 0 there. Now perform the subtraction. From which side we will start? Just like the decimal number arithmetic operational. We will start performing subtraction from the right side. So rightmost bit of any binary number is called as the LSB, that is least significant bit, which is having the lowest weighted value. So the LSB of the first number is 1 and of the second number is also 1. So 1 minus 1 is 0. 1 minus 1 result is 0. No need to take borrow. Next 0 minus 1. See, 0 minus 1 result is 1 and we need to take borrow also from the next column. So here we will write the result as 1 and borrow is 1. So I will write minus 1 in the next column. Okay. So again, now next one is 1 minus 0 and minus 1. I will write here 1. Bit of the first number is 1. Bit of the second number is 0. So 1 minus 0 and minus borrow. So first take the subtraction of first two bits. 1 minus 0, its result is 1. And now subtract this minus 1 or subtract this 1 from the result. So 1 minus 1 equal to 0. So here result is 0. Next 0 minus 1. Again 1 is greater than the 0. So we need to take the borrow from the next column and the result will be 1. 1 minus 0 minus 1. Again the same case. 1 minus 0 minus 1. Result of 1 minus 0 1. Subtract the next one from the result. So 1 minus 1 0. So these are actually borrow. So here I will write shortcut B. Okay. So this is the result of subtraction of the given two numbers. Now I want to verify, I want to cross check whether whatever result is there, whether it is correct or not. So for that, what we have to do? First, we will convert these given binary numbers into its equivalent decimal. So for that, we should know how many bits are there in given binary number. 5 bits are there. So I will write total 5 weighted values. 1, 2, 4, 8 and next one is 16. I will write the first number 1, 0, 1, 0, 1. Now, see the weighted values below which 1 is written. Why? Because 1 represents that particular weighted value is selected. So, 16, 4 and 1. So, I will add those weighted values. 16 plus 4, 20, 20 plus 1, 21. So, the decimal equivalent for the first number is 21. Now, find out the decimal equivalent for the second number. Second number is 0, 1, 0, 1, then 0, double 1. What is selected? 8, 2 and 1. So 8 plus 2, 10, 10 plus 1, 11. So the decimal equivalent of the second number is 11. Okay. Now find out the decimal equivalent of the result also. What is result? 0, 1, 0, 1, 0. Okay. So where 1 is written? For 8 and for 2. That means 8 and 2 is selected. So 8 plus 2 is 10. That means the decimal equivalent of this result is 10. Now 21 minus 11, the result must be 10. Is it 10? Yes, it is 10. So this result is correct. So this is how we can verify whether our answer is correct or not. Now let me start with the second example in which I will consider the integer as well as the fractional part. Second example, suppose the given binary numbers are 1011, 0.01, minus 101 point 101. Okay, these are the binary numbers, so the base is 2. Now I will write the first number 1011.01. I will write the second number from the right side, 101. This is the binary point. Okay, and after binary point, what is there? 101. Now see, integer part of the first number contains 4 bits. Integer part of the second number contains 3 bits. So simply add 10 to the left of this, so that now you can see 4 bits are there in both of the integer parts. Okay. Now here fractional part of second number 3 bits. In fractional part of the first number only 2 bits are there. So to make 3, I will add 0 to the right side. And here I will write the borrow. This is added 0 and this one is also added 0. In integer part we will add 0 to the left side, and for the fractional part we will add 0 to the rightmost side as per the requirement, because it will not affect the value. Now we will start with the subtraction from the rightmost bit. So here the rightmost bit of the first number is 0 and of the second number is 1. So 0 minus 1. 0 minus 1. Result is 1 and the borrow is also 1. Now this will become 1 minus 0 minus 1. 1 minus 0 minus 1. So 1 minus 0 is 1 and minus 1. So the result is 1, 1. Sorry, 1 minus 1, 0. Next, 0 minus 1. 0 minus 1. The result is 1, borrow is also 1. So write the result and borrow is 1. And where is binary point? Yes, it is here. Now the next, 1 minus 1, result is 0. So here I will write 1 minus 1, 1 minus 1, and then subtract the borrow also. So 1 minus 1, its result is 0, minus 1, 0 minus 1, result is 1, borrow is also 1. So result is 1, borrow is also 1. Again it will become 1 minus 0, 1 minus 0, and then subtract the borrow also. 1 minus 0, 1, minus this one. 1 minus 1, 0. So the result is 0. Next one is 0 minus 1. So 0 minus 1, result is 1, borrow is 1. Here 1 minus 0 minus 1. So actually here you can even ignore this 0, because when we subtract 0 from any number, again it will not affect the value. So 1 minus 0 is 1 and then 1 minus 1 is 0. So this is how we can perform the binary subtraction. For binary subtraction we must know all the rules. There are 5 rules. So this is very simple method to perform the binary subtraction. If you have any doubt, then you can post comment in comment box. I will answer it. And if you like the video, please share it with your friends. Don't forget to subscribe my channel and click on the bell icon also to get the notification of my next uploaded videos. Thank you.